the Panther tank. Now a turbine is theoretically more reliable and easier to maintain than a piston engine, since it has a simpler construction with fewer moving parts, but in practice turbine parts experience a higher wear rate due to their high working speeds. Means more the speed, more will be wear rate, more will be friction and more consuming power. Now the turbine blades are highly sensitive to dust and fine sand, so that in desert operations air filters have to be fitted and changed several times daily. Next comes the marine applications in naval. Now the gas turbines are used in many naval vessels where they are valued for their high power to weight ratio and their ships resulting acceleration and ability to get underway quickly. Now the first gas turbine powered naval vessel was the Royal Navy's motor gun boat MGB 2009, converted in 1947. Now advances in technology. Now gas turbines technology has steadily advanced since its inception and continues to evolve. Now development is active in producing both smaller gas turbines and more powerful and efficient engines. Now the main drivers are computer design and development of advanced materials. The base materials with superior high temperature strength or the thermal barrier coatings that protect the structural material underneath from even ever higher temperatures. Next comes the aircraft gas turbine engines. Now the most of modern passenger and military aircrafts are powered by gas turbine engines, which are also called as jet engines. Now there are several types of jet engines, but all jet engines have some parts in common. Now aircraft gas turbine engines can be classified according to number 1, the type of compressor we are using, and second by the power usage produced by the engine. First comes the compressor types that we are using. On the basis of compressor type, these are of 3 types: centrifugal flow, axial flow and combined centrifugal axial flow. And on the basis of power usage being produced, they are as follows: turbojet engines, turbofan engines and turboshaft engines. First comes the centrifugal compression engine. Now the centrifugal flow engines, they compress the air by accelerating air outward perpendicular to the longitudinal axis of the machine. Now the centrifugal compression engines, they are divided into again 2 types: single stage and 2-stage compressor. Now the amount of thrust is limited because of the maximum compressor ratio. Now principal advantages of centrifugal compression: first is that they are of lightweight, they are very simple, and third one is of their low cost. So this is a single stage compressor and this is a 2-stage centrifugal compressor. Second one is the axial flow. Now axial flow compressor engines, they may incorporate 1, 2 or 3 spools. Let me tell you what is a spool. Spool is defined as a group of stages rotating at the same speed. In case of 2 spool, there are 2 rotors which rotate independently. This is a single spool, this is a 2 spool engine. Next comes the axial centrifugal compression engine. Now the centrifugal compression engine were used in many early jet engines. The efficiency level of single stage compressor is relatively low, but we can say that the multi-stage compressors, they are somewhat better than the single stage. So this is a centrifugal flow compression. This is a combined centrifugal and axial flow. Next come the characteristics and applications. The turbojet engine drives its thrust by highly accelerating a mass of air, all of which goes through the engine. Now since a high jet velocity is required to obtain an acceptable of thrust, the turbine of turbojet is designed to extract only enough power from the hot gas. Next is the turboprop engine. The turboprop engine delivers its propulsion by the conversion of the majority of the gas stream energy into mechanical power to drive the compressor, condenser or any other accessory. Next comes the turbofan engine. Turbofan engine has a duct enclosed fan mounted at the front of the engine and driven either mechanically at the same speed as the compressor. Next comes the turboshaft engine. Turboshaft engine drives its propulsion by the conversion of the majority of the gas stream energy into mechanical power to drive the again the various accessories, compressor, condenser or we can say the turbine. So, this is the turbo fan, turbo shaft and turboprop. Next come the advantages of the gas turbines. There are two big advantages. Gas turbine engines have a great power to weight ratio compared to the reciprocating engines. Gas turbine engines are also smaller than their reciprocating counterparts of the same power. Next advantage is that the gas turbine plant is simple in design and construction. It has only few reciprocating parts and is lighter in weight. Means if as there are few reciprocating parts, so wastage will be or energy loss will be less and the efficiency will be more. The gas turbine is quite useful in the regions where due to scarcity it is not possible to supply water in abundance. Next comes the other advantages include it moves in one direction only, it has few moving parts, the wastage is very less, there is a great reliability in case of turbines as compared to reciprocating parts. So, high operating speeds, low lubricating oil cost, they can run with a wide variety of fuels. Next comes the disadvantages. The main disadvantage is that as compared to reciprocating engine, they are expensive. This is the main disadvantage, they are really very expensive. They also tend to use more fuel when they are idling, meaning when they are moving idle, they still use fuel very much. So, this makes the gas turbine very expensive. So, this is the summary. So far we have read about the introduction, the history of gas turbines, classification, gas turbine power plant, open type gas turbine power plant, closed type gas turbine power plant, fuel used, types of gas turbines, aircraft gas turbines, advantages and disadvantages. Thanks.